Object-oriented design and programming, standard template library. What is standard template library? It's like a toolbox for C++ programmers. It's got all sorts of handy tools you can use to make your code more efficient and easier to write. Imagine you are building a house and you have a toolbox full of different tools like hammers, screwdrivers, and wrenches. Each tool has a specific job, right? Well, that's kind of how the STL works. In this toolbox, you will find things like lists, stacks, and arrays. These are all different ways to organize the stored data. So if you need to keep track of a bunch of items in your program, you can use one of these data structures from the STL to make it easier. But the STL isn't just about storing data. It also include algorithms which are like step-by-step instructions for performing common tasks like sorting a list of numbers or searching for a specific item. So STL offers an assortment of containers. It publicizes the time and storage complexity of containers. Containers grow and shrink in size automatically. So it also provides built-in algorithms for processing the containers. So it has four components. One is the container, second one is the iterators, third one is the algorithm, and fourth is the functions. Okay, so today's class we are going to discuss about STL containers. STL containers have different types like sequence container, container adapters, associative containers, unordered associative containers. In sequential containers, we have some types like array, vector, DQ, forward list. In associative container, we have the concept of set, multiset, map, and multimap. Unordered also having some types like unordered set, map, and multiset, multimap. Okay. Sequence container. In sequence container, we have the types like arrays, vectors, DQ, list, and forward list, right? Okay. So here arrays. Array. What is meant by array here? Arrays are containers of fixed size. They hold a specific number of elements. These elements are arranged in a strict linear sequence. Vectors. So vectors are those array containers that can change their size. Like arrays, vectors use contiguous memory locations to store their elements. However, unlike arrays, the size of the vector can change dynamically, with their storage being handled by the container automatically. DQ. DQ is this one. So here we have the concept of like double-ended queue. A DQ is a container whose size can increase or decrease dynamically on both ends. Forward list are a sequence containers that allow insert and erase operation in constant time anywhere in the sequence. Forward lists are implemented as single listed linked list. Hence, each element for a forward list can be stored in unrelated memory location. And what will be called as list? Like forward list are sequence containers that allow insert and erase operations in constant time. In the constant time. Okay. So next one is about the container. In container, we are going to discuss about the vector. Okay. So what will be the called as vector? Vectors are same as dynamic arrays with the ability to resize itself automatically when an element is inserted or deleted, with their storage being handled automatically by the container. Vector elements are placed in contiguous storage so that they can be accessed and traversed using iterators. In vectors, data is inserted at the end, and inserting at the end takes differential time, as sometimes they are be in need of extending the array. Removing the last element takes only constant time because no resizing happens. Inserting and erasing at the beginning or in the middle is linear in time. So in functions, what are the functions associated with the vector? So iterators, capacity, element access and modifiers. So what are the iterators supported by the vector? So begin, end, or begin, or end, C begin, C end, CR begin and CR end. So we can see some example program for representing begin, end, C begin, C end, R begin, R end, CR begin and CR end. So here in this program, main it declares a vector named GL without any elements. Next, it enters a loop that runs for 1 to 5. 1 to 5. So after this loop, GL contains the elements 1, 2, 3, 4, 5. Then it prints output of begin and end to indicate the starting of printing of element G1. Next one is about C begin and C end. So they start another loop using the constant iterators C begin and C end. These iterators are constant beginning, meaning that they cannot modify the elements of the vector. It prints each element again with this constant iterator. So again we'll be getting the answer as 1, 2, 3, 4, 5. Next one is about like reverse begin and reverse end. So reverse end, that is nothing but like it traverses through the element of G1 in reverse order. So inside the loop it prints each element in reverse order. Next one is about CR begin and CR end. So to indicate the start of the printing the elements in reverse order again using the constant reverse iterators CR begin and CR end. So we are getting again answers 5, 4, 3, 2, 1. Okay, in this program here this is normal begin end concept, so we can able to print 1 to 5 numbers. Here this one is representing the C begin and C end. So here what will be happen is we won't get the proper output here, it will show error because the attempt to update the elements of the vector using constant iterators obtained from C begin and C end. C begin and C end. When you declare auto I v dot C begin and I I less than v dot C end, so which means it's an iterator that promises not to modify the elements it points to. This makes sense because C begin and C end return constant iterators indicating that the elements they point to should not be modified. So here we cannot modify the value. So if you are trying to modify the elements by adding 5 to each element with the statements, this contradicts the promise of constant iterators and will result in a compiler error. Next is about the capacity. So in capacity we have the functions like size, max size, capacity, resize, empty, string and reverse. So in this program we use the concept of gl.size, capacity, maximum size. So size will be used to print the size of the array. So here 1 to 5 we asked to print, so size is 5. Capacity is 8. So it will according to the system it will show the limit, and what is the maximum size of the particular vector also will be shown here.